The main sources of DC electrical power are the transformer rectifiers, one for each main DC bus. The main DC buses share a DC bus tie breaker located in the DC bus tie. The DC bus tie breaker is normally open and closes only in case of failure of the associated TR or AC bus, and then only if both AC bus tie breakers are in auto. The left DC bus normally serves as the primary power source of the center DC bus, the standby DC bus, and the battery bus. Now note, the position of the standby power switch has no bearing on the left or right DC bus powering the battery bus. In case of a complete failure of the AC generating system, including the hydraulic-driven generator, the aircraft electrical system is reduced to the aircraft battery for its sole electrical power source. This battery standby power system includes 4 electrical buses and an inverter that converts DC power to AC power for the standby AC bus. The battery standby power system includes these 4 buses: hot battery bus, standby DC bus, standby AC bus. Let's now describe the purpose of these buses. The hot battery bus supplies power to the systems that need continuous electrical power. Items that are powered by this bus are fire extinguishers and the fire extinguishing electrical power, SPAR and APU fuel valves, IRS emergency power, left and center continuous, right for 5 minutes only, RAT manual deployment, clock time reference. Before APU, external, or engine generator power becomes available, the battery is the power source for the hot battery bus. With APU, external, or engine generator power available, the battery charger is the hot battery bus power source. Before generator electrical power is available, the battery bus can be powered by the hot battery bus through the battery switch-operated battery switch relay. With the battery bus connected to the hot battery bus, the battery discharge light illuminates, indicating that the relay is closed. The battery bus powers a number of items. Some important ones are engine, APU and cargo fire detection, DC fuel pump, RAT automatic deployment, standby engine indicator, forward cockpit dome lights. If the battery switch is not on after generator electrical power is established, the battery switch off light illuminates. An ICAS will indicate a battery off advisory message. Before generator electrical power is established, the standby DC bus is powered by the aircraft battery through the standby power switch, auto or battery position. Some of the important items powered by this bus are standby attitude indicator, left VHF communication system, manual cabin pressurization system, bleed air isolation valve. After generator electrical power is established, the left DC bus is the principal power source for the standby DC bus, with the main battery operating as a backup power source. If the standby DC bus should lose power, the standby power off light illuminates, and ICAS displays the advisory message of standby bus off. Before generator electrical power is established, this bus too is powered by the aircraft battery and the standby inverter through the standby power switch auto or battery position. Some of the important items powered by this bus are left VOR receiver, left ADF, RDMI, center ILS receiver, main instrument panel floodlights. After generator electrical power is established, the left AC system through the left AC transfer bus powers the standby AC bus. If the standby AC bus should lose power, the standby bus off light illuminates and ICAS indicates an advisory message of standby bus off. Checking the battery standby power system. The entire battery standby power system can be checked by turning the standby power selector to battery. The battery position isolates the system from the battery charger, making it entirely dependent on the battery for electrical power. Consequently, the battery discharge light illuminates. The standby power off light should remain out when the battery is selected, since the standby buses should be powered.